Hello. In Unit 1, we discussed the birth and death of stars and speculated on the origin of the universe. Well, in today's lesson, we will just look at one of those trillions of stars, which is our dear Sun. Is that right? That gives life to the Earth. Well, we will look at the system that the Sun consists of, the solar system. Now, what is the solar system made of, and what are the components of the solar system? Now, here we have a picture of the solar system. Solar system is made up of the Sun, the planets, the asteroids, the comets, and so on. So the solar system consists of the Sun, the 8 planets, more than 130 satellites, a large number of small bodies, the comets and the asteroids, and all these make up our universe. Now, we're going to divide the universe into two parts. The inner solar system, no, not the universe. We are going to divide the solar system into two: inner solar system and the outer solar system. Now, look at the inner solar system. The planets Mercury, Venus, Earth and Mars make up the inner solar system. The distance between the Earth and the Sun, this is something that I would like you to remember. 1 astronomical unit, and that distance is 1.5 times 10 to the 8 kilometer, which is 150 million kilometers. So the distance between the Earth and the Sun is called 1 astronomical unit, in abbreviation AU, and it is 150 million kilometers. The gravitational attraction between the Sun and the planets is responsible for holding the planets and the solar system together. Now, the planets of the outer solar system. What are the planets of the outer solar system? We have Jupiter, Saturn, Uranus and Neptune. Although Pluto was a planet some time ago, at the moment it is being declassified and now it is called a planetesimal. It doesn't qualify to be a planet. We will talk about it why. Now, the outer solar system consists of Jupiter, Saturn, Uranus and Neptune. I have also shown Pluto here. One of the reasons why Pluto was removed from the planets list is it does not conform to the normal behavior. If you look at the yellow track, that is the orbit of Pluto around the Sun. It crosses the orbit of Neptune, which is uncharacteristic of planets. So one of the reasons why Pluto is removed from the list of planets is that it crosses the orbit of Neptune. Another reason is it is a very small body. It's actually smaller than our moon, little bigger maybe. Alright, Pluto was demoted from its planetary status in 2006 due to its small size and its peculiar orbital behavior. The main asteroid belt is between Mars and Jupiter. If you look over here, I don't know whether you can see this. It is in this region that you find the main asteroid belt. We will talk about that as we go on. The solar system is mostly empty space. Well, we talked about this and I cannot emphasize it more. The universe as a whole is virtually empty space. Although it is made up of trillions and trillions of huge stars, It is virtually empty space. The space between stars is so huge that the space that the stars themselves occupy is very small. In a similar way, the solar system is virtually empty space. Why? Because looking at the total space, the space occupied by the planets and the sun is very, very small. The planets are very small compared to the space between them. The orbits of the planets are ellipses with the sun at one focus. Now, though all except Mercury and Pluto are very nearly circular. Now, what is an elliptical orbit? Let me show you, give me a second to show you how an ellipse looks like. An ellipse is actually an elongated circle, and whereas a circle has a center, you see, a circle has a center, an ellipse has two foci. Focus, the plural is foci. Now, there is one focus here, another focus here. Now, if this is a planet Earth, then the sun is at one of the foci. And the characteristic of an ellipse is described by its eccentricity. Its eccentricity. Now, what does eccentricity mean? You see, if the orbit is a circle, the eccentricity is 0. It is not eccentric. But as the orbit gets flatter and flatter, the eccentricity increases. Alright, so we will be talking about these as we go on. Okay, let's continue now. The orbits of the planets are all more or less in the same plane called the ecliptic. Now, if you take the path of the Earth around the Sun, now that is in one plane. If you take the path of Mercury around the Sun, it is also in the same plane, and that plane is called the ecliptic. Now take a note of that. We will be looking at that again. So what is ecliptic? Ecliptic is the plane that contains the path of the Earth around the Sun. Now what does that actually mean? A plane that contains... Now what that means is, now can you understand that this is a plane? The Earth will be moving in that plane. The Mercury will also be moving in that plane. Jupiter will also be moving in that plane. And this plane where the planet orbits the Earth is called the ecliptic. Now, it is particularly important for the Earth. We will look at that later. The ecliptic is inclined only 7 degrees from the plane of the Sun's equator. That means the plane where the planets orbit the Sun is almost the same as the plane containing the... Now let me show that. Now if this is the Sun, the equator of the Sun is this, is that right? Now can you consider a plane? What is the plane that contains the equator? Now I can say this is the plane. If I make it all around, that is a plane that contains the equator. That means all the planets are actually orbiting the Sun more or less in that plane. Well, that plane is approximately inclined to the plane containing the equator of the Sun by about 7 degrees. But Pluto's orbit deviates the most from the plane of the ecliptic with an inclination of 17 degrees. And they all orbit in the same direction, that is counterclockwise, looking down from above the sun's north pole. What does that mean? If you look down from the north pole, they all go counterclockwise. They all go in that direction. Now, so that is the direction in which the planets all go around the sun. Okay. They also rotate in the same sense, except Venus, Uranus and Pluto. Now, what does that mean? You see, this is the sun. All planets revolve around it in the clockwise direction, and along with their going around the sun, they also rotate, and the rotation is also counterclockwise. That's what it means. But Venus, the rotation of Venus is clockwise. If Earth rotates like this, counterclockwise, Venus rotates in the opposite direction. Similarly, Uranus and Pluto, of course, is not a planet. So I hope you got the concept of the planets going around the sun in counterclockwise direction, and they also rotate in the counterclockwise direction, except Venus and Uranus. How about the relative sizes of the planets? How big are they when compared to each other? Now, imagine a model in which everything is reduced by a factor of 1 billion. That means bring down the sun to 1/100000th of what it is. Bring down the Earth to 1/10000000th of what it is. Bring down the whole solar system to 1/10000000th of what it is. Now, how will it look? Well, the Earth would be about 1.3 centimeter in diameter. Now, can you watch over here where I'm pointing? The Earth would be about 1.3 centimeter. In that case, the Earth will look like a small grape. Now, where will be? The Moon would be about 30 centimeter from the Earth. So, if the Earth is this little grape, the Moon will be about 30 centimeter. If you can follow my pointer, the Moon will be somewhere there, at that scale. The Sun would be 1.5 meters in diameter. The Sun would be about 1.5 meters in diameter and can be seen 150 meters from the Earth. So, in that scale, the Sun would be about 1.5 meter. Now, imagine a sphere of 1.5 meter. That's about the relative size. And what will a human be in that scale? A human on the scale would be the size of an atom. But the nearest star, alright, this is where I want to appreciate why the solar system or the universe is empty space. When you bring down the solar system to 1/100000th of its size, where is the nearest star? The nearest star would be over 40,000 kilometers away. You see, when we fit in all the solar system in this room, the nearest star would be almost as far away as the Moon itself. You can see how empty the universe is. Alright, now look at the relative sizes of the planets. If this is the Earth, that is Venus, so the size of Venus and Earth are almost the same. And look at a little Pluto. How many Plutos can fit into Earth? So no wonder Pluto is declassified as a planet. Mercury is a very small planet. Mars is the red planet. So have a look at the relative sizes of these planets. Alright, now I have put in the giant planets. Look at Jupiter. Now, When Jupiter is of this size, look at Earth. How many Earths will fit in Jupiter? Jupiter is a great giant planet. In fact, if Jupiter had more mass, it probably would have become a star by itself. In fact, Jupiter actually emits its own light. Because of the mass that it contains, the gravitational contraction actually produces the tremendous temperatures required for the emission of light. Alright, now I have put the Sun here and all the planets, and look at the relative sizes. That is our little Earth, little dot there, and all these planets, the giant Jupiter, where is the giant Jupiter compared to the size of the Sun? You see, if you put all these planets, it will just take a small corner of the Sun. So appreciate that relative size. Our poor Pluto cannot even be seen in this scale. Okay, now look at this. I have now shown some relative sizes of stars. You see, in the previous slide, the Sun looked very big compared to the planets. Now look at this now. I have shown some other stars. This is the star Sirius, this is the Pollux, and this is the Arcturus, and look at the size of this massive star. And here is our Sun. You see, our Sun is now so small, millions of these can actually fit into this star. So I want you to appreciate the relative sizes of stars, the relative sizes of planets, and most of all, that the universe as a whole is actually empty space. I have a table here which actually compares the size, the diameter, and all these compared to Earth. Now, this is the Earth. The Earth has 1 unit diameter, mass, the distance from the Earth. What this means is, if this is 1 astronomical unit, then Uranus is 19.18 astronomical unit from the Sun. So look at this chart and get a picture of relative sizes, distances, the way they orbit around the Sun. This is a summary of all statistics about the planets. Okay, planets can be classified into 2 major groups based on size, density, and the nature of the atmosphere. The inner planets are Mercury, Venus, Earth, and Mars, and they have similar densities and compositions. So all these inner planets are very similar in their density and compositions. Therefore, they are called terrestrial planets. They have the terrestrial characteristics. All their terrestrial characteristics are the same. So what are the terrestrial planets? Mercury, Venus, Earth, and Mars. Outside the terrestrial planets, you have the giant planets. Now, you understand why they are now called giant planets. Because Jupiter, Uranus, and Saturn are really very big compared with the terrestrial planets. Now, terrestrial planets are mainly composed of rocks and metallic nickel and iron, and that is what gives them higher density. Average density of Earth is about 5.3 gram per milliliter. It's about 5.3 times the density of water. Whereas the giant gas planets are composed mainly of gases, hydrogen, helium, and methane. So these giant planets have almost the same makeup of stars. But because they didn't have enough mass, they haven't become stars on their own right. Now the giant planets are separated from the terrestrial planets, I showed that to you, by the asteroid belt. Now, where is the asteroid belt? Asteroid belt is the space between Mars and Jupiter. You see, Mercury, Venus, Earth and Mars are the terrestrial planets. Then Jupiter, Saturn and Uranus are the giant planets. Separating the two, you have the asteroid belts. We will now have a closer look at each of the planets. We will not spend a lot of time, but take a glancing look at each of the planets. First, let's have a look at Mercury. Now look at a picture of the surface of Mercury. How much pockmark is on Mercury? What do you think is the reason for all these craters and pockmark on the surface of Mercury? Well, Mercury was named by the Romans after the fleet-footed messenger of gods because it seemed to move more rapidly. You see, Mercury goes so rapidly around the sun. Why? Because it is the closest planet. And as a result, the Romans named it Mercury after the fleet-footed messenger who could run very fast. Alright, Mercury is the closest to planets and it is slightly larger than the Earth's moon. It's only slightly larger than the Earth's moon. And one important characteristic, Mercury has no atmosphere. You see, when you have no atmosphere, that means you cannot see anything. Why are we able to see our sky blue? Because our atmosphere scatters the light. And most of the scattered color, you know that white light is made up of several colors. And most of the scattered color is blue. And that's why we see it blue. We have a beautiful blue sky. We see it because we have the atmosphere. If there is no atmosphere, there is nothing to scatter the light. So if you look up on Mercury, what will you see? A great big darkness. The atmosphere will look dark. Now Mercury is very bright and appears only briefly after sunset and sunrise. It is rather difficult to see Mercury from the Earth. It looks like a bright star, but it is visible only at sunrise and sunset. Mercury completes one orbit around the Sun in 3 Earth months. That means in 1 year, it goes around the Sun 4 times. Mercury rotates 1.5 times during each orbit. Now, you are familiar with the Earth, I'm sure. The Earth, as it goes around the Sun, how many times does it rotate when the Earth goes around once around the Sun? You can see it rotates once every day. That means when it completes one revolution around the Earth, it completes 365 rotations. But how many times Mercury rotates? Only 1.5 times. So if you start here, when it comes over here, it completes the first rotation. You see? And now comes over here, completes the second rotation. And so on. It completes 3 rotations in 2 complete rounds. When it makes 2 complete rounds, it does 3 rotations. What is the implications of that? Now, this means that very high temperatures on the surface that faces the Sun. So, that means the surface that faces the Sun will be facing the Sun for a very long time. So, you have very hot days and very cold nights. Is that right? Because there will be very long nights and very long days. The absence of atmosphere makes long nights very cold. You know why? Why is the Earth warm? Because As the earth receives the energy from the sun, most of the energy gets reflected back, but the atmosphere absorbs part of it and reflects back to the earth. It is the atmosphere, particularly the gases like carbon dioxide and water vapor in the atmosphere, that keeps the warmth on the surface of the earth. In the absence of these gases in the atmosphere, earth would have been very cold. So, because Mercury has no atmosphere, all the heat it receives from the sun, it radiates, it's reflected, it just escapes to the space. And so, the nights are very, very cold. The days are very, very hot, because that's the time the energy from the sun falls on the Mercury. The night is the time when the energy is reflected back. So the nights get very cold and the days are very hot. The surface temperature on Mercury ranges from melting point of lead. So during the day, if you keep a piece of lead, if I have a piece of lead, well, if you keep a piece of lead on the surface of Mercury, it will melt. And at night, oxygen will turn into liquid because of the low temperature. So Mercury's orbit is highly eccentric. You understand the meaning. I explained to you what eccentricity means. The orbit is highly eccentric means it deviates from the circular path quite a bit. And at perihelion, it's only 46 million kilometers from the Earth. What is perihelion? Perihelion is the nearest approach. So when Mercury is here, that is perihelion, and that distance is 46 million. And aphelion is when it is farther out, and that distance is about 70 million. So you can see the orbit of Mercury is much more elliptical than Earth's orbit. Its eccentricity is much more than the eccentricity of Earth's orbit. So that's the perihelion and that's the aphelion. Mercury has been visited by only one spacecraft, that is Mariner 10. And only 45% of the surface of Mercury was mapped. Well, a new Discovery class mission to Mercury, Messenger, was launched by NASA in 2004, and it will orbit Mercury in 2011. We hope to get more information on Mercury from that mission. Mercury has no natural satellite. Our Earth has one moon. Mercury has no moons. Now, Mariner 10 showed that Mercury has a magnetic field, like Earth has a magnetic field, but it is a very, very weak magnetic field. And the source of that is not known. Well, we can leave it at that. Mercury has a high density of about 5.44 gram per centimeter cube. It's almost the same as the density of the Earth. Alright? And what does that indicate? It indicates that 60 to 70% by weight, the core, you see the core is the densest because that's where most of the metals are. It indicates that it has a large core of 60 to 70% by weight made of metals and 30% by weight of silicate. So the large density of Mercury is an indication that it has a very hard core made of metals. Well, I have a picture of some part of Mercury. Mercury is marked with great curved cliffs that were apparently formed as Mercury cooled and shrank a few kilometers in size. In the initial stages, Mercury and all planets were actually molten rock. And as it cools, it begins to shrink. And as a result of shrinking, it produces the curves, the ups and downs, and that is the surface features you see there. The shrinking produced wrinkled crust. Earth also has a wrinkled crust caused by the cooling and solidifying of molten rock. Well, let's now look at our next planet, that is Venus. Venus is the most beautiful planet. Look at the beauty of it. And isn't Venus the planet of beauty? Yes, the goddess of beauty is Venus. Well, I have given you the size and distance. Take note of these. Venus is the goddess of love and beauty. The planet is so named probably because it is the brightest planet known to ancients. Now, if you can see Venus during the evening hours or very early in the morning, it is the brightest star that you can actually see in the sky. When I say star, it is not a star, it's a planet. But it looks like a star when we look at it from here. Venus is a bright star that appears near sunset and sunrise. It has phases like the moon. In other words, phases means only part of it will be visible on each day, and the amount of the surface that you can see will keep increasing depending on the position and the light that falls on it from the sun. We will talk about the phases of the moon as we go on to explain that further. When it is full, that means when Venus is fully visible, it is farthest from the earth. That is when all of its surface gets full light from the earth, from the sun. So when Venus is farthest from the earth, that is the time when it is full. A crescent Venus is closer to the earth and appears brighter and bigger. Why? When it is closer, it will appear bigger. Now, the first spacecraft to visit Venus was Mariner 2 in 1962. Now, there I have a picture of Mariner 2 visiting Venus. It was subsequently visited by many others, including Pioneer and the Soviet Venera 7, the first spacecraft that actually landed on Venus. So Soviets have been pioneering space travel before actually America took over and succeeded in landing on the moon. So Soviet Venera 7 first landed on Venus and sent back some spectacular pictures. This is the picture sent back by Venera 9. Now, US spacecraft Magellan produced radar maps of Venus. Now, this is the picture produced by the US spacecraft Magellan, but these colors are false echoes. They are not the real color of Venus. Now, Venus is sometimes regarded as the Earth's sister planet. Why? Because in many ways, Venus and Earth have common characteristics. Now, Venus is only slightly smaller than the Earth. When I showed you the relative sizes, you saw the Venus and Earth are almost of the same size. It's about 80% of Earth's mass and 95% of Earth's diameter. So, look at the common characteristics. Both have few craters indicating relatively young surfaces. That means the surface of the Earth and Venus were not bombarded as frequently as were in the cases of Mercury and other planets. You saw the surface of Mercury. It is pockmarked with bombardment. But Venus and Earth don't have that kind of pockmarks, indicating that maybe these planets are relatively new, didn't have a lot of time for these missiles to come and hit us. The densities and chemical compositions of these two planets are similar, and therefore they are called sister planets. The pressure on Venus's atmosphere is about 90 times the pressure on the surface of the Earth. Now, we will be looking at the concept of atmospheric pressure. You see, we have an atmosphere that presses us. We are subjected to atmospheric pressure. Now, this pressure on the surface of Venus is 90 times what is on the surface of the Earth. So tell me, if you go to the surface of Venus, what will happen to you? You will be squeezed to the size of a grape because of that great pressure. You see that? So, atmospheric pressure plays a great role. Our bodies are made to withstand the normal atmospheric pressure. Now, if you go to a low pressure region or a high pressure region, our bodies will not cope. Alright, we will talk about that as we go on. It is mainly composed of carbon dioxide, and that's why the pressure is very high. Carbon dioxide is a very heavy gas. So Venus's atmosphere is mostly made of carbon dioxide. There are several layers of clouds, many kilometers thick, composed of sulfuric acid. You see how toxic the atmosphere of Venus is. And this dense atmosphere produces a greenhouse effect. You see, carbon dioxide is a gas that can absorb radiations that are reflected from the surface and then re-emit it. That will heat up the atmosphere very much. So that greenhouse effect makes the surface temperature about 740 Kelvin. So the surface temperature of Venus is very high, mainly due to the greenhouse effect produced by carbon dioxide. Venus probably once had large amounts of water, but that's all probably boiled away. And now it may be the least hospitable planet in the solar system in many ways. It's very hot. Its atmospheric pressure is 90 times the pressure on the Earth. The atmosphere is made of carbon dioxide and sulfuric acid, and so on. Most of Venus's surface consists of flat, rolling plains. There are also several broad depressions deeper than the Grand Canyon and two large highland areas higher than Mount Everest. Well, Venus, like Mercury, has no satellite. So, the first planet from the Sun that has a satellite is our dear Earth. We have one beautiful satellite. Don't we love it? Alright, we'll talk about our moon as we go on. The data from Magellan's imaging radar shows that much of the surface of Venus is covered by lava flows. In other words, Venus has been and even now is very volcanically active. And you can see this is the picture of an active volcano, lava coming out and flowing into the surrounding regions. There are several large shield volcanoes such as the Sif Mons, and this is the Magellan radar picture of Sif Mons, which is a shield volcano. Now, Venus is still volcanically active. Even now, it is volcanically active. Is Earth still volcanically active? Yes, it is. Alright, but only in a very few hot spots. For most part, it has been geologically quiet for the past few 100 million years. Alright, Magellan's image show interesting features, and I want you to take a note of that. Like pancake volcanoes, which seem to be eruptions of very thick lava. Look at this. Eruptions of very thick lava which got solidified and collapsed into domes. Very interesting features. So when lava came up, they are so thick they collapsed as domes. Instead of flowing away, they sort of constructed domes-like structures, and we call them pancake volcanoes. That is one interesting feature of the surface of Venus. Now, this is a coronae. I have some statistics of Venus about the mass, the equatorial radius, and so on. Well, just for information only. Alright, let's now have a look at Earth's moon. We are coming closer and closer from the Sun. We started with Mercury, Venus. Now we will look at the moon, our dear moon. Have you ever seen the picture of moon through a telescope? Now it looks like this. It has a lot of craters on it. Alright? Now it is 384,400 kilometers from the Earth. And its diameter is 3,476 kilometers. Alright. Now the moon has been known since prehistoric time. Nobody can miss it, because that is the most bright object in our night sky. Is that right? And the most beautiful. People have made poems and, well, stories and all kinds of things about the moon. In fact, people seem to fall in love in moon's light. Is that right? There are many people who have sung about that. So it is the second brightest object in the sky after the sun. Well, the first brightest is our sun. Well, look at this. As the moon orbits around the Earth once per month, the angle between the Earth and the moon and the sun changes. We see this as the cycle of the moon's phases. Well, if I can show you, well, I don't know whether you can actually see it well. There you have, well, let me see if I can just show you the Earth. Now, this is the Earth, and that's the moon there. And as the moon goes round, well, that's the moon there. Now, as the Earth rotates and the moon goes around, there you are. Now, the plane of the moon's orbit will keep changing. And it is that plane, the changing plane, that creates the phases of the moon. And we will look at that in a little more detail. Alright. Now, the time between successive new moon is 29.5 days. That is slightly different from the moon's orbital period. The moon goes around the Earth in 29.5 days. Let's now look at the phases of the moon. What is it that gives rise to the phase of the moon? Now, from any location on the Earth, the moon appears to be a circular disk which at any specific time is illuminated to some degree by direct sunlight. Now, if you can have a look at this, let me see if that is visible there. Now, this is the sun, and if you have the moon here, well, can you see that moon over here? There, you can see the moon going around the Earth. Now, when the moon is here at this point, actually the sun is blocking it. So all the light now falling on the moon is on this side. That means the poor people on the surface of the Earth will not see the moon. That's the new moon. Whereas when the moon is on the other side, you can see as the moon continues, the amount of light. Let me see if I can. As the moon continues its journey, I want you to have a look at this. Well, you can see the amount of light falling on the moon and what we see from the earth increases. Alright, now we can see half of the moon, and when the moon is now right behind the earth, alright, now that's the time. Can you see the moon is now fully illuminated, and that is the new moon. So as the moon goes around, the portion of the moon that gets illuminated is what we see, and the portion of the moon that is illuminated keep increasing until we get the full moon, and then it decreases until we get the new moon. Alright, here I have a picture. You can see the portion of light, the portion of moon surface illuminated increases, increases, increases until we get the full moon, and then the portion of the moon surface illuminated decreases until we have the new moon. Now I'm going to take these and divide it into 8 parts and show them to you one by one. 8 distinct, traditionally recognized moon's phases. Now here is the new moon. That means this is the time the moon is between the earth and the sun, isn't it? The moon is between the earth and the sun. Well, if this is the earth, that's the moon, the sun is in front of it. That means all the light falling on the moon, you can see here, my projector is the sun. All the light falling on the moon is on the other side. From the earth, you see the moon as a dark object, and that is the new moon. Now, as the moon rotates, you can see now, as the moon goes around, the amount of lights that illuminates the surface of the moon changes, and it is at this time, you see the full moon there on the surface of the earth. Now you have full moon. Alright, let's go through those 8 steps. Now this is called the waxing crescent. The moon appears to be partly but less than 1/2 illuminated. That means this time the part of the moon illuminated is actually increasing. And now you have the first quarter. 1/2 of the moon appears to be illuminated. And this is the waxing gibbons. Now the moon appears to be more than 1/2 but not fully illuminated, and the fraction of the moon's disk that is illuminated is increasing. And there you got the beautiful full moon. And now what happens? The next one is, now so far we were in the waxing stage where the fraction of illuminated area increases. Now we are in the waning stage. Waning gibbons. Alright, what will be the next one? This is now the last quarter. 1/2 is illuminated and the fraction illuminated is decreasing, and this is the waning crescent, and finally you end up with the new moon. Let's now talk about lunar surface. What do we know about lunar surface? We know a lot about lunar surface because our buddies have been there. They brought back materials. They told us a lot about moon surface. There are 2 primary types of terrain on the moon. The heavily cratered, you saw with all the craters, or the heavily cratered and very old highlands, and the relatively smooth younger portion called Maria, meaning sea. Now here you can see the cratered part and look at the darker area. It's a darker area that is called Maria. The highlands and Maria. The Maria, which comprise about 16% of the surface of the moon, are huge impact craters which were later flooded by lava, so molten rock, and that probably gave it that dark shade. Well, most of the surface is covered with a substance called regolith, a mixture of fine dust and rocky debris produced by meteor impact. You see, as the meteor impacts the surface, it pulverizes the surface, making everything into fine powder. And that substance is called regolith. In fact, most of the surface of the moon is composed of that regolith. Some unknown reason, Maria, which is the darkest side, is on the near side. You know that the moon is only half of the moon is visible from the earth, the other half is not visible. You know why? Because as the moon goes around the earth, its period of revolution and the period of rotation is exactly the same. When the moon goes around once, it also rotates once. That means the same point is facing the earth every time. We never see the other side of the moon. Well, we know about the lunar visits. The moon was first visited by the spacecraft Luna 2 in 1959. Again, Soviets did that first. This is Luna 2. Now, it is the only extraterrestrial body to have been visited by humans. Is that right? The moon is the only extraterrestrial body that have been visited by humans. The first human landed on the moon on July 20th, 1969. And you are familiar with this picture, is that right? Apollo 11. And you see the footprints of Neil Armstrong, and you see our American flag. This is the lunar module, and so on. And what did Neil Armstrong say? A small step for a man, a giant step for mankind. That has been a great leap in scientific exploration of space. Let's now talk about lunar gravity and tides. Tides on the earth are produced by the gravity of the moon. The gravitational forces between the earth and the moon cause some interesting effect. The most obvious are the tides. You see, the gravity produced by the moon is felt much more closer on the earth. You see, suppose that's the moon and this is the earth. The gravitational force due to the moon is felt more on this side than on the other side. That's what that picture means. The gravitational force is felt more on the near side than on the far side. That means Earth gets pulled towards the moon, more on the near side and less on the far side. So the moon's gravitational attraction is stronger on the side of the earth nearest to the moon and weaker on the other side. Since the earth, and particularly the oceans, is not perfectly rigid, it is stretched out along the line towards the moon. Now, because the earth rotates much faster than the moon moves in the orbit, the bulges, you see, that gravitational pull produces a bulge on the ocean. And because the moon goes around the earth, that bulge will travel around the earth. So the tides are felt all over the earth. Now look at the bulge here. As the moon pulls the ocean, now the bulge on this side is due to the moon pulling it, and the bulge on the other side is because the earth itself moves inside water, leaving a bulge on the other side. So you get two bulges, one on one side, the other on the other side. So the liquid at point A is closer to the moon and experiences a larger gravitational force than the earth at point B or C. Alright? So we got two bulges. The bulge on this side is because the water gets pulled, and the bulge on this side is because the earth is pulled away from water, creating that bulge on that side. A given point on the surface will experience two high and two low tides for each rotation of the planet. You know that. And also look at the difference between neap tide and spring tide. Neap tide occurs when the sun and the moon are at 90 degrees. The sun pulls the earth that way, the moon pulls it this way. And so the bulges are not as pronounced as they are now here. When the moon and the sun are on the same side, they work together. They pull together, you get greater bulges. So the spring tides are much more pronounced than neap tides. Alright? So distinguish between neap tides when the moon and the sun oppose, whereas spring tides occurs when they pull together. Alright. The moon dust brought back by Apollo astronauts contained microscopic glass beads. Now, the moon does not have an atmosphere, and so the meteorites falling on the surface vaporizes the rock material, and you know that if you melt rock, it produces glass. And that must be the origin of glass on the surface of the moon. Now, the rocks on the surface of Maria are mostly basalt, a type of rock formed by solidification of lava. Alright, so we have an understanding of the type of surface the moon is made of. The rocks brought back from the moon contained a substantial amount of radioactive elements, which made it possible for us to measure the age of the moon, which is calculated to be about 3.1 to about 3.8 billion years old. That's about, the moon is as old as, well, that's about the solar system, I suppose. Now, how did the moon originate? Let's briefly discuss that. The moon is believed to have formed due to the impact on the earth of a very large object, the size of Mars or larger. You see, during the time when Earth was taking shape, a very large object came and hit the Earth, breaking part of it and vaporizing it. You see, the origin of the universe, such violent acts were very prevalent. So this collision is believed to have vaporized colliding objects and part of the Earth. Some of the debris condensed away from the Earth, forming the moon. That is how our moon is formed. With the exception of few craters, the surface of the moon has not changed for the last 3 billion years. You see, because the moon does not have any atmosphere, the surface will not change. It is the atmosphere that creates the weather conditions. It is the weather conditions that creates erosion and things like that, that changes the surface. Because the moon does not have an atmosphere, none of these happen. The surface of the moon has been remaining like this for the past several billion years. Well, I just outlined the solar system talking about Mercury, Venus, and our moon. We will, in the second part of this lesson, I will talk about the other planets, mainly the giant gas planets, the asteroids, and many other things. Alright, I will see you for that in a little while.